Hello class. Today we're going to look at evaluating expressions using the T-chart. The standard that we're working with right now is a 7th grade standard, and it says that we're going to represent linear relationships using verbal descriptions. That's when we are reading and writing expressions. That's what we're doing when we're doing verbal descriptions. Tables, which is the same thing as a T-chart, which is what we're working on today. Graphs, which is what we'll work on tomorrow. And equations that simplify to the form of y equals mx plus b. And we'll be working on that over the next 3 weeks. So let's review. First thing I want you to do is evaluate each of these expressions for those given values. And we know to evaluate, all that really means is to replace your variables with the values that I said that they are. So the first thing I want you to be able to do is interpret it. Okay, so this 3x plus y really means 3 times the value of x plus the value of y. So that means we're going to take the 3, we're going to multiply it by the x value, which is 6, and then I'm going to add the y value, which is negative 5. Okay, so this basically is 3 times 6 plus negative 5, which gives me 13. We're going to do the same thing to the other one. Now, the other one we got to be very careful with, because this one says I'm going to do 2 times the value of x minus 3 times the value of y, get an answer for that, and then I'm going to divide that by z. Okay, so that means I'm going to do 2 times 6 minus 3 times negative 5, and I'm going to take that and I'm going to divide that by 4. So to work this on the calculator, if we were to pull up a calculator, you pull up my calculator real fast, slide it over a little bit so it's not taking up so much room. If I were to type that in exactly as it's written, 2 times 6 minus 3 times negative 5, divide by 4, the calculator is going to do order of operations, and it's actually going to do the 2 times 6 first, then it's going to do the 3 times negative 5, and then it's going to divide that answer by 4. Okay, so when you do that one, you're going to get this as an answer, but that's the incorrect answer. 15.75 is not the correct answer, because what we need to make sure of is that we get an answer to that top before we do the bottom. So in order to do that, what you're going to have to do, if you want to type it in all the way like that, is put the top part in parentheses. So if we do parentheses, 2 times 6 minus 3 times negative 5, close parentheses, that's going to force that to get an answer. Then I'm going to hit divide by 4, which actually gets an answer of 6.75. So just because you're using a calculator doesn't mean that you're going to get the right answer. So you've got to make sure that you do it correctly. So today what we're going to do is we're going to look at evaluating expressions with T-charts. So when we evaluated expressions, what I did so far is I've changed the expressions, but I kept the values the same. So I gave you a set number of values, and I gave you a whole bunch of expressions to use with that. So what if I flip that? What if I gave you one expression but gave you multiple values? Kind of like this one. This one says, take that 2x plus 3 and evaluate it for every one of those variables, every one of those values for x. Okay, because x is a variable, which means its value can change. So that basically means we would take the 2x plus 3, and I would do the first time 2 times 0 plus 3 and get an answer of 3. And then I would do it again, 2x plus 3, and I would do 2 times 3 plus 3, and I'd get 9 as an answer. Then I would do 2x plus 3, which is 2 times negative 2 plus 3, which would give me a negative 4 plus 3 gives me negative 1. And you would do that for every one of those values. But there's got to be an easier way. And sure enough, there is. Okay? We use a T-chart in order to organize our information and our data. So this is the same exact information that we just looked at, but it's just organized in a way that we can understand. Because what algebra is about is looking for patterns. So in order for us to look for patterns, we have to organize it in a certain way. If you'll notice, right here my x values are just kind of thrown up there. 0, 3, negative 2, 1, negative 1, 2. Well, if we put them in order in a T-chart, this is what they look like. Negative 2, negative 1, 0, 1, 2, 3. So there's a pattern on the left side of that T-chart, so there better be a pattern on the right side of that T-chart. So what I need you to understand is that this T-chart says something. Okay, it says, if x is negative 2, then 2x plus 3 is what? So that's the question that this is asking. So what we have to do is evaluate that. Okay, so what we're going to do with the t-chart is we're going to draw a little line right down here. Now, eventually that line will go away, but we need to understand that we have to put our values, our answers, in this location right here, okay? So I draw a line and we show our work off to the side. So the work that we're going to do is we're going to take that -2 and we're going to plug it into that expression. 2 times -2 plus 3, and we're going to get an answer. So 2 times -2 is -4, plus 3 gives me -1. And then we're going to do it again because my x value changes. So now it's 2 times -1 plus 3, because now my x is -1. So 2 times -1 is -2, plus 3 gives me a +1. Then we're going to do one more time because now my x is 0. So 2 times 0 plus 3. 2 times 0 is 0, plus 3 gives me 3. Now, what that allows me to do by evaluating 3 x values is that now lets me see what the pattern is. And you'll notice to go from -1 to 1, it's counting by 2s. To go from 1 to 3, that's counting by 2s. So that means to go from 3 to the next value, I'm going to count by 2s. So that should be 5, and then 7, and then 9. So we don't necessarily have to show as much work, okay, whenever we're organizing things in the t-chart, because we can begin to see a pattern. Okay, so let's try another one. So here's the next one. Okay, and this one says, if x is -2, then 3x minus 2 is what? Okay, and that's what we're trying to look for. Okay, so in this particular one, when I see I'm dealing with integers and I've got a minus, I'm going to change my minus to a plus next to its opposite. And then I'm going to evaluate for the first 3x values. So now I'm going to draw my line down, and we'll do 3 times -2, because that's what my first x value is, plus -2, and then I do my math. If you need to do that on the calculator, you're more than welcome to. So 3 times -2 is -6, plus -2 gives me -8. And then I do the next one, because now my x value is -1. So 3 times -1 plus -2. Well, 3 times -1 is -3, plus -2 gives me a -5. And then 3 times, because now my x is 0, times 0 plus -2. 3 times 0 is 0, plus -2 is -2. So what are we doing to go from each of those values? I'm adding 3 each time. Adding 3. So to go to the next one, I'm going to add 3, which will give me a +1. And if I do the next one, I add 3 again, I end up with 4. Now, if you have trouble looking at what the numbers are going to be, you can use a number line to kind of help you. And we noticed that our first number was -8. We increased to -5. So what did I do? I added 3. So the next one, I'm going to add 3 more, and that gets me to -2. So that means I add 3 more, and I get to, well, this would be -1, 0, and then 1. Okay, so we know that it's 1. So you can use that number line to help you count. And if we are going to the right, that means it's an increasing pattern. If I'm going to the left, it would be a decreasing pattern. So let's try another one. So what if I gave you this one? This one says if x is -2, then -2x plus 6 is what? Okay, so pause the video and answer this one on your own. Okay, so let's find out how you did. So in this one, we're going to show our work. So I'm going to draw my line, and we'll write -2 times, well, my first x value is -2, plus 6. Okay, so that's going to be -2 times -2, which is going to be +4, plus 6 gives me 10. And then now my x value is -1. So -2 times -1 plus 6. -2 times -1 is +2, plus 6 gives me an 8. And then one last one to show the work on, 0. So -2 times 0 is 0, plus 6 is 6. So what are we doing in this particular pattern? In this one, instead of increasing, we're actually decreasing by 2. Okay, so I'm going to decrease by 2 to get to the next one, which is 4, and decrease by 2 to get to the next one, which is 2. Now, what I want you to kind of notice is what happened in this particular problem. In the 2 previous problems, my pattern increased. I was counting by 2, counting by 2, counting by 2. In this pattern, I was counting by 3s. I was increasing by 3. So what happened in this one? I was decreasing by 2. So what do you think caused that decrease? Good. The -2, the coefficient. Okay, that number right there determines which direction I'm going. But if you'll also notice, that number also determines our pattern. Okay, so on this one, I'm decreasing by 2. This one, I'm increasing by 3. This one, I'm increasing by 2. And each time, what was that coefficient? It was the same exact thing. So that's one of the things I need you to pay close attention to. In class, we're going to talk about where does this other number come into play? Because that number's got to do something. Okay, if the first one's got some bearing, the second one also has to do something. And we'll talk about that in class. So let's look at this next one. Okay, so what if, in this one right here, I was increasing by 2, increasing by 3, decreasing by 2. What's this one going to do? Well, based on our pattern, it should increase, because it's positive, we're adding, by 0.5. Okay, so again, I'm going to change my subtraction to addition next to its opposite, and then I'm going to plug in my values. 0.5 times negative 2 plus negative 2. Well, 0.5 times negative 2 is going to give me a negative 1, and negative 1 plus negative 2 gives me a negative 3. And then we go to the next one. 0.5 times negative 1 plus negative 2. Well, 0.5 times negative 1 is going to give me a negative 1/2. And negative 1/2 plus negative 2 gives me a negative 2 and 1/2 for 0.5. And then 0.5 times 0 plus negative 2. Well, anything times 0 is 0, plus negative 2 gives me a negative 2. So what am I doing? Am I really increasing by 0.5? Yes, I am. So if we were to continue that pattern of increasing by 0.5, the next one should be negative 1.5 and then negative 1. Okay, so same things happen. Okay, so what if I gave you a fraction? Could I flip that to a decimal if I wanted to? Yes, we could. We could flip that to a decimal, or we could keep it as a fraction, either one. So in this one, we know that that fraction is going to give me a nice pretty decimal of 0.75. So yes, you could use 0.75 times negative 2 plus 1. So if you go to your calculator, I'm not going to pull it up on the screen. I'm going to just use a calculator by hand. So 0.75 times negative 2 plus 1, I end up with negative 0.5. And we do the next one, 0.75 times negative 1 plus 1. And what would you expect to happen? Hopefully it's going to increase by 0.75 or 3/4. Okay, so 0.75 times negative 1 plus 1 gives me 0.25. And is that an increase of 0.75? Yes, it is. So if I do one more, 0.75 times 0 plus 1. Well, again, we know anything times 0 is 0, plus 1 gives me 1. And then if I'm increasing by 0.75, the next one should be 1.75, and then the next one should be 2.5. So it does continue the same thing. Now we got one more problem to look at before we get to the assignment, and that's this one right here. What if I have a fraction that's going to give me a repeating decimal? Well, if we have one of these, we have no choice but to keep the fraction. But you'll also notice in this one, there's not a plus or minus anything. It's just 1/3 x. So that means all I'm doing is I'm taking 1/3 and multiplying it by that x value. So this first one's going to be 1/3 times negative 2. Now, do you remember what we have to do with fractions? To multiply fractions, you got them. It's top times top and bottom times bottom. Now, that was not really the nice little rap that I did in class, but you get the idea. So we make this negative 2 a fraction, and this one ends up being negative 2/3. Negative 2/3. Okay, now, because it's a repeating decimal, I can't give the decimal. I have to give it as a fraction. So then we do the next one. 1/3 times negative 1. Now, what do you think is going to happen? Okay, this one says I'm increasing by 1/3. Okay, is what that pattern actually says. So this one right here is going to be, turn this into a fraction. 1 times negative 1 is negative 1/3. So negative 1/3. Is that increasing by 1/3? Yes, it is. So then the next one, since we're just doing times 0, we know that's going to give me a 0. And then again, I'm increasing by 1/3, so that's going to be 1/3, and then 2/3. So sometimes when you're given fractions inside your equation, or your expression, you're going to have to give fractions as answers because of the repeating decimal. You're not allowed to use a repeating decimal in class, okay, or on anything. So what you're going to do for your assignment is you're going to just fill in some T-charts. Okay, so you're going to have 9 T-charts that I want you to do, and you're doing just exactly what we were doing. You're going to draw your line down. You're going to show me the work for the first 3 x values, and then you're going to fill in the rest with the pattern. So until next time, I'll talk to you later.